And welcome to the first annual episode of Benched. Yes, of course, in sports, we know being benched is not necessarily a good thing. You've been stuck and relegated out of the game. But in this case, you are going to get ready to get into the game. In this case, the little insane piece of the insanity is for a test called the bench. You know them, you love them. The benchmark test. And this one is a doozy. Now, what are we going to do? We are going to be walking through this entire process, dealing with some of the topics that will show up on this thing. Now, some of these things we've dealt with, and we understand that we totally get. However, some of them are going to be review, like this, for example. Atomic nudes. Now, this is the naked atom. It's got the very basic pieces of it. Now, you have your electron, and you have your nucleus. Now, the three pieces... I really don't like it when it decides to, move ahead on its own. How about we go back? Can we go back? No? It's like going forward. It's the only thing we can do. It's bloody thing. You go forward, not backwards. So previous. Bloody hell. Previous, and previous, and previous, and previous, and bloody freaking previous. God freaking. Why does it want to keep... So we have these parts here. I should turn off the touch action. So, the electron. The electron is, of course, the thing that binds reality. And, reality. And everything you see is electrons. As a matter of fact, the way that you see is electrons. Moving back and forth between energy levels, producing electromagnetic waves that allow you to actually see things. Now, but the weight of the atom, the mass of the atom... The weight, everything that is the mass, comes from the nucleus. And the nucleus hosts two different particles, the proton and the neutron. And if it weren't for the neutron, all of these protons would simply blast away at super high speeds, because we know that plus charges will push away from each other. But the neutrons, they stick all of these things together, kind of like a glue. So the atomic structure thing here is basically need to know that the mass is located in the nucleus, and the electrons are responsible for binding and holding all of the atoms together. That's pretty simple, pretty straightforward. Now, if we were going to read this in terms of the periodic table, and we asked for things like the atomic number. What does that really mean? What is atomic number? Well, the atomic number is simply the number of protons, and I think most of us remember this, protons being the positive parts of the nucleus. So the protons sort of provide the atom's ID number, like a jersey number on a football team. There's no multiple number 42s. There's only one per team, and so that ID number becomes the atomic number, or the player's identification. Now there we have the symbol here, and that's the atomic symbol. In this case it's for carbon. And the atomic mass. Now, as we said previously, that mass is due to two things: protons plus the number of neutrons. Now you'll notice too that as the elements get bigger, the more there's huge amounts of positive charge in the nucleus. And that means we need a disproportionately larger number of neutrons to try to bind the nucleus together. So you'll notice that the smaller atoms, things tend to be very even, like 6 and 6. But when you start to get higher in things like, let's say for example, chlorine. Now, chlorine has a, atomic mass of 17, but its mass is 35. So that means it's got 18 to 19 neutrons, depending upon what isotope you're dealing with. Now you notice that it's starting to get a little wonky, a little disequalized, and that's because the elements are getting larger and there's more positive charge building up inside the nucleus. So we've got that part kind of taken care of. We know what all of these numbers mean, so we're moving on, getting something a little bit more complex. This is all basic stuff. You totally got this. This is, as you're well aware, the periodic table. Now, the periodic table is, as you know, divided up into neighborhoods. Now, this area here, these vertical columns, they are referred to as groups. Now, this is the group 1A. This is group 2A. Now, they also have specific names that they go by, and these are the names. You probably recognize them as alkali metals. And, of course, 2A would then be what? Well, that's right. The earth alkali metals. So these would be, there's 2A, there's the earth alkali metals. And so if we were going to look at these, and there are a couple other well-known areas of the periodic table. For example, this area right here. These are the elements that have all of their electrons in their outer energy level filled up. There's no extra electrons. They are all completely paired up. And they don't interact with anyone, so hence they have earned the name noble gases. Now, these guys here have also a special name. These guys here with fluorine, chlorine, bromine, they have been called, you probably remember this, the halogens. Now, I just kind of like to remember them as sort of the halogens, because I was a big fan of the game, so I called them halogens just to ignore and completely irritate all of the people who knew chemistry around me. So halogen, it's not a halogen, it's not like bloody is. Talk to Master Chief, he'll tell you the exact same thing. But doesn't really necessarily matter. I said that these are probably the ones that you want to get faced most frequently. The noble gases, halogens, earth alkali metals, and the alkali metals. Now, these guys here we remember as transition metals, and these are the metalloids right here. They're not sure what they are. They, you change the heat or the pressure, and they change their thing. They might be metal one minute and non-metal like the next. Depends on the conditions. So the hoods of the table, gone over this. I think you're about to get this. All right, now. Girls are about sharing. A long time ago, I believe we talked about how girl relationships were a lot about sharing things. And in covalent bonding, co meaning with, valent meaning valence electrons, or the electrons that are on the outside part of the shell, those are the electrons that are moved to other atoms to be shared in electrical bonding. So in this case, this is ammonia. So if you remember back when we were smelling that horrible smell that we were making the reaction that got cold, and we mixed ammonium chloride with the barium hydroxide, and it made ammonia gas, and it was stinky. But ammonia gas has a nitrogen, and it's sharing 2 electrons between the hydrogen and the nitrogen. So there's electrons, 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 and they're represented by a single line. Now that is a single bond. Now, if you're going to have a double bond, you might have something like carbon dioxide. Now, carbon dioxide has 2 sets of electrons sharing with oxygen there. And that's what that would look like. They're represented by lines. Now, in a more, graphical representation, we might represent them as this, whereas these electrons, the ones that have dots, are coming from the nitrogen. Those are the lone pair extras from nitrogen, and the X's are coming from the hydrogen. And so you notice that a bond requires 2 electrons, and they're being shared between 2 non-metals. And that's very important because, as we'll see in a second, the metal atoms, they go about things very differently. We talked also to girls about sharing. Boys, they're more givers. They're more, I'm going to give you something. I don't necessarily need it back. But see, the fact that I can just give you something like a brother, then that's great, because that's the bond that holds us together. In this case, so if you had sodium and chlorine, now these little dots on the outside, we'll talk about these a little bit later. These are officially called Lewis dot structures, and they're a little foolish. This is where they put electrons on the outside of the atoms to simply do one thing, and that's to show how many electrons that each of the atom would want to either accept or give away, so that they could get to the magic 8, which is basically all the electrons that the noble gases have, like neon, and they have all of their electrons all buddied up, and then they're all like perfect and happy and everything, and they're all like Kardashian and all, and then they have Twitter accounts and all that bloody stuff. So basically all of the elements want to get to this configuration, and sodium does it by giving electrons away, and chlorine does it by getting electrons and parking them in their extra, slots that they have open for them. Now in this case, when that electron is given away by sodium, and that's what metals do. Metals give their electrons away. But in the process of doing that, see, there it is, the chlorine now has an extra negative electron, which makes the chlorine negative. And now because the electron from sodium has left, that means that sodium is positive. And you know what happens between opposites. There's two P's in that. They attract. And so those positives and minuses are going to stick together. They're going to stick like magnets. And that's what's going to hold them together. And that magnetic attraction, that's called an ionic bonding, because it's bonding essentially between ions, charged particles. And that charge is what holds them together.
Okay, Google. Good job.
This dinosaur is 12 feet tall and about 43 feet long. It's bigger than most balloon sculptures anyone's ever seen before.
Get in the hole. That's it. That's it. Yeah, did it go in?
While I do this, why don't you grab your proof of insurance and your driver's license quick?
Yes, sir.
There, you should be able to adjust it.
Okay, thank you so much.
Coming off that two-game losing streak.
Spread it. Form. Spread it. News.
And he has gone from a bad free throw shooter to an excellent free throw shooter. You just don't see young kids doing this anymore, but he can make them.
All right, so this is perfect for testing the grappling hook gun.
Your hand is in at all times. and works to counteract any unwanted movements so that you can relax and enjoy the company of those around you instead of worrying about the task at hand.
And they make something different.
High five! Ow!
Now, in this case here, we're going to talk about clicks. You know what a clique is, right? A clique is sort of like a grouping of people that have sort of something in common. They're bonded together by whatever means or manner. Now, in this case, this is hydrochloric acid. It is an acid that has a covalent bond, a highly polar covalent bond, and there is a very strong push to have all of the electrons over here, and that's why you've got this little squiggly that's represented as a partial negative charge, and this is a partial positive charge. Now, in this case, that means that these partial negatives will be attracted to partial positives and will hold these cliques together. So it's like all the goths right over here, so they're all gothic, black and depressed. And so if you have a partial positive here and a partial negative here, as it appears that, look, as we said before, they attract. So guess what happens? There is an attraction force between this partial positive and this partial negative. That's brilliant. And this is the reason why water is considered a polar fluid. Polar means it has charges. It has electrical poles on the molecules. And this is why they mix with other stuff that is polar. Now, for example, things that are non-polar, and as you know, non-polar things do not mix with polar things. They just don't do it. But a non-polar fluid would be like gasoline or oil, where there's a lot of carbons and hydrogens and things stuck together, and there are no partial charges. That's the difference. So gasoline and oil, no partial charges, and they like to hang out on their own. Water, hydrochloric acid, like ammonia, sulfates, sulfides, all of those polyatomic ions, they're all polar and they all mix with water. It seems pretty straightforward, right? Like dissolves like. Now it's time for an epic win. A little break and enjoy your epic win session.
Here they come. All right. Nice Letterman. Wow. Wow, look at this.
You are looking at an Atari 2600 emulator that I built in Minecraft. So here is Pac-Man for the Atari 2600. It is widely regarded as being one of the worst ports to the Atari.
Merry Christmas, everyone, from Snug Harbor on Prosperity Farms Road and their traditional Christmas display.
Masaluke is inside the penalty area as well, and it heads over to Masaluke. Look at him. Keeper goes on the adventurous route. Masaluke scores!